So, a little disappointment. I didn't get the discovery I was hoping for. I only got 2 to 4 picowatts out of this, and then only on vacuum tube capacitor number 3 and 4. Again, from 0 watt inputs. So, what would you expect from zero? I mean, I can get more watts than that from 20-foot grounded aerial. I can get half a volt. Actually, I don't know what current I can get from that. So it might be comparable, but I certainly won't get the volts I can get. Although this took 5.5 seconds, or excuse me, 501 seconds. I decided to make it slightly offbeat just in case the simulator was goofing with me if I did whole factors of 10, powers of 10. So less than 1 picoamp in the positive and negative direction. This was, let's see, VTC3 on the top, where's my finger, up here, is less than 450 femtoamps, and from vacuum tube capacitor number 4, it's in the negative, complete opposite orientation, and it's less than 300 femtoamps in 501 seconds. Then here's the circuit. Basically, it's the same as before. It's got a spark gap in the form of a neon bulb in between 2 capacitors, and flanked on either side by 2 lightweight inductors, 1 microhenry each. The capacitors are 135 femto farads. I didn't monkey with the spark gap, other than the fact that I varied the integer values of the capacitances, the gap capacitance of 1 picofarad and the arcing capacitance of 3 picofarads. I added a tiny fraction to it to make sure the simulator did its job and didn't goof around. Then I added a Fullbridge diode to rectify the current, and all I did was increase voltage. So I was able to shrink the amount of time it took to reach a nice target, 175 volts. I don't think I've gotten to that schematic yet. And so that reached it in 500 seconds. Not bad. But I did have to in order to do that, I had to have a pico. I could have lowered this and gotten things even more drastic, I think. No, actually, it becomes, no, I think a picofarad is in the range. A picofarad and up, I think up to 1 microfarad is the window. But below a picofarad, it's a disadvantage. But then I had to raise the coil inductances on this transformer to 100,000 henries. Well, the table model of Joseph Newman's over unity device had, I think it was 10,000 henries on his table coil, which weighed 300 pounds. It was a tiny little thing. Yet it was solid copper. The node voltage there is, it looks like 800. Yeah, 800 volts on the left-hand side, negative, and 45 negative on the right-hand side. And I'm not sure why it's such a big difference on both sides, because the capacitors are the same, and the coils, the henries are the same. So I don't know. I do put a diode here. It's all habit. I didn't try taking this out to see if it would help any. Maybe it would have. Yeah, who knows? Maybe for next time. Everything else I left the same. So I measured these over here because these are 800 nodal voltages. Well, 8 versus 980. While here, it's 804 versus 864. So I thought, bigger difference over here. So I'll take it, and it tends to be that way over on this side. Not sure why. It must be because the source is closest. In any case, maybe I should try taking out that diode and see what happens. Maybe try taking out this capacitor, because the voltage on this capacitor is less than the voltage on this capacitor. So maybe I don't need anything over here except the ground. Well, I need something, probably a tiny resistor. I ought to try that, because that might be competing with this side, and if it's reducing the voltage on this side, for sure it's going to be impacting the other side, and then I could shrink the amount of time it takes to reach my target. So that's the the nodal voltages. That's the circuit. Okay, so here's 175 volts, and this is pretty much the same voltage on both the VTC 3 and 4. And that's it. So there goes my video.